Welcome, everyone. I'm Michael Greenlee. I'm the lead UC architect at Clarity Consulting. And with me is Vijay Manian, who is a senior development lead at Microsoft. I'm very excited to be here at the conference, and it's great to see so many people interested in Lync development topics. You know, Lync development has become a lot more common than it was when I started. When I started out with Lync or OCS, but it's still fairly specialized among Lync topics. And of all the Lync development tools, probably the most poorly understood, but also the most powerful, is the Lync Server SDK. And in this session, we're going to talk about the Lync Server SDK, what you can do with it, and how it works. The session is divided roughly into 3 parts. So I'm going to start with some background, not specifically about the SDK, but actually about message routing in Lync Server, how messages are structured in Lync, and some other things that are very important to understand in order to use the SDK effectively. So those of you who have some background in the Lync Server SDK or just in Lync development in general, you may be familiar with some of this already. So I'll just ask you to bear with me as I go through some of the basics, and we'll get to some more advanced material shortly. After that, we're going to talk about the SDK itself and when you might use it, what are some scenarios where it's useful, how it works, how you can set up and configure your applications, and some of the different components that make up the SDK. And then I'll hand over to Vijay, and Vijay will show some demos and some sample code to give you an idea of how to use the SDK and how to get started with it. And then we'll finish up with some time for questions. So the first topic I want to cover in Lync Server routing in general is Session Initiation Protocol, or SIP. SIP is really the primary protocol that Lync Server uses to set up and to manage communication sessions. So it doesn't handle real-time media, it doesn't handle audio or video streams. That's done with some other protocols. It's used for setting up the sessions, getting them connected, and exchanging information that's used for media transmission. SIP is actually a fairly standard protocol in communication platforms, not just Lync. It's defined in a document called RFC 3261, which comes from the IETF. And you can find the link for that document here on the slide. It's a very long and detailed document, so it's not necessarily a good place to go for an intro or a summary, but it's great if you want to look up something specific about the protocol, how messages are structured, what a specific header means, or something like that. And Lync actually has its own sort of dialect of SIP, which adds some extensions that support things like presence and conferencing that aren't covered in RFC 3261. They're not part of SIP out of the box. And although Lync has its own dialect of SIP, or its own version of SIP, you can still use SIP to interoperate between Lync and other SIP-based communication platforms. And that's, in fact, one of the things that you can do with the Lync Server SDK is help facilitate communication between Lync and other SIP-based devices or platforms. And the one caveat there to be aware of is that Lync actually sends its SIP messages over TCP or TLS, whereas most other SIP-based platforms use UDP. So you need to make sure to account for that.
The structure of a SIP message is in a lot of ways similar to HTTP messages. So for any message you have a first line, which for a request includes the method name, for a response has the response code. Then you have a series of headers, which are name-value pairs, and those have information that's being passed with the message. And then finally you have a body, which has the content of the message. So as an example, when you're setting up a call, that's a SIP invite request, and the body of the message in that case is the information that Lync uses to negotiate media between the endpoints. Another important SIP concept is user agent. You'll hear this a lot as you start going through development with the Lync server SDK. And a user agent is just a network endpoint that sends or receives SIP messages on behalf of a user versus for some other purpose. In Lync server, there are two different types of user agent in SIP terminology. There are user agent clients and user agent server. And again, if you compare to HTTP, it's very much the same as to what's a client and what's a server. The client is the thing sending the request, and the server is the thing receiving it and sending the response. Now in Lync server, a user agent, like the Lync client, can be either a client or a server from a SIP perspective. So they sort of switch roles depending on who's initiating the conversation, for instance. Most of you are probably familiar with SIP URIs, which are the identifiers for a user or an endpoint in Lync server. One thing that I want to call out, though, that becomes important as you start looking at modifying routing and modifying the content of messages is that there are really two types of SIP URIs that come into play in Lync server. There are logical SIP URIs, which identify something like a user and which can span multiple devices or network locations. And then there are physical SIP URIs, which are tied to a particular device and a particular network location. So a lot of what Lync server does, and a lot of what SIP platforms in general do, is taking logical SIP URIs and figuring out the corresponding physical SIP URI in order to route the message to the appropriate location. And when you develop with the Lync server SDK, one of the things that you have control over that you don't really have in any other set of APIs is the ability to influence what exactly is the mapping between those logical and physical SIP URIs and what process Lync server goes through in making that determination. In SIP, there's this concept of a proxy server, which is the thing that does that determination of what's the physical SIP URI or SIP URIs that correspond to the logical SIP URI, the user's SIP URI. In Lync server, the proxy server is basically the front end. And there are also these several other roles in SIP terminology, the registrar, the location server. And the way it works is when a user signs in, they're registering using a SIP register request with the registrar. The registrar is also in Lync, part of the front-end server. And that tells the registrar and the proxy server where to locate the user later. What's the physical SIP URI that messages for that user can be sent to. And that's stored in some sort of data store, which is the location server. Then when another user wants to communicate with this person, instead of trying to locate the user directly, they just send the message to the proxy server. So in Lync, that's the front end. And the proxy server checks where is that user located right now and passes the message along to the proper location. I want to talk a little bit now about the structure of SIP messages. So if you look at the first few lines of a SIP message, particularly in this case an invite request, probably the most important things that you need to look at for routing purposes are in these three lines that I have up here. So the first line is the request line, and that has the method name, which is in this case invite, and then it has what's called the request URI, and that tells Lync server where is this message going to from a network perspective. Then you have the to and from headers. So these two SIP headers identify the destination of the message in the to header, and then the origin of the message in the from header. And those are logical SIP URIs, or in this case what we call addresses of record, AORs, because they correspond to, they're the SIP URI of record for particular users, but they don't identify where the user is located at this moment. When a message comes into the front-end server, it will usually look something like this, or those lines will look like this. You'll have an address of record as the request URI. So at this point, we don't know on the network where this message is going to. What happens next is the front-end server makes a determination of where to send the message, and that request URI then changes to a logical SIP URI. So it now identifies the server or the specific location where we need to route the message to. And then the front-end server sends it off to that location, and it gets to the user at the correct endpoint. One other thing that you see a lot of, especially once you get a physical SIP URI, the request line, is what are called URI parameters. And these are sort of these key value pairs that are tacked onto the end of a SIP URI, and that give additional information, often about where to route the message or what's being done with it. A few examples of where you see this. If you look at the URI, the SIP URI for a conference, for an audio-video MCU, for example, that has a bunch of URI parameters which tell Lync server, we're not routing this request to the user, we're routing it to a conference that belongs to that user. And as you look at the destinations of messages with Lync server SDK, you see a lot of those, and sometimes you need to manipulate them. One more concept that has what I think is kind of a funny name is forking. Forking is just splitting a message into multiple branches when it goes out of the front-end server. So if you have a user who's signed into multiple devices, then when a SIP invite message comes in for them, the SIP invite being the message that initiates a call or an IM or some other type of conversation, when that invite arrives at the front-end server, the front-end server doesn't know where that user wants to answer the communication. So it just sends it to all of that user's endpoints. And that process is called forking. And each of those branches goes to its own endpoint, and then whichever endpoint answers with a 200 OK, which is the signal that conversation can now be established, that endpoint sort of keeps the SIP session, and the other endpoints get a notification that we don't need you anymore. You can drop out of this conversation. Forking is another thing that you have control over in the Lync server SDK. You can determine which endpoints out of a user's endpoints get the SIP messages from Lync server. A specific type of URI parameter that's important in routing, and that I'll cover a bit more later, is tags. And tags help to uniquely identify a branch of a conversation, or a particular conversation between two endpoints. Because if you look at the contents of the from and to headers, those are going to have addresses of record. They're going to have SIP URIs that can correspond to multiple Lync endpoints. So what the tags do is they say, we're talking about this branch of the conversation that went to this particular endpoint, and not to the other one over there that we also contacted. And so tags are an important part of identifying a conversation and a particular branch of that conversation. And one last case where you see URI parameters is in what are called GRUs. This stands for Globally Routable User Agent URI. A GRU is a unique identifier for a specific endpoint. So unlike an address of record, which can span multiple endpoints, this uniquely identifies a particular user agent, and it's routable theoretically from anywhere. So the idea is that regardless of where you are on the network, if you have this GRU, you know exactly where to send the message that you want to send. You don't have any questions about which endpoint it's going to end up at. So Lync server uses GRUs when it wants to get a message to one specific endpoint. It doesn't want to branch it to multiple locations. It doesn't want to potentially have it redirected. It just wants to send it to one specific endpoint representing one specific user. And the way you can identify these is that they have this GRU parameter in the URI. and that identifies it as a GRU for Lync server. One final concept I want to talk about is the concept of a SIP session or a SIP dialog. So when SIP messages are going back and forth between two endpoints, the first message that's sent, which is often a SIP invite message, kicks off the session between the two endpoints. The session is identified by this call ID header along with the from and to tags, those parameters that I talked about. And as long as that SIP session is active, there's some state that's associated with it in Lync server and the endpoints that are participating. So the SIP session is used to do things like control an ongoing audio call or an IM. And you can identify the different messages that belong to the same session by looking for that call ID header and the from and to tags and tying them together that way. The first message in a SIP session, as I mentioned, is often an invite. The last message is a bye. So when you see that SIP bye request, that means the session is being concluded and the two endpoints are no longer communicating. It is important to understand that the SIP signaling, as we call it, the messages that are going back and forth in the SIP protocol, don't carry media for most types of conversations. Except in IM sessions, when you kick off something like an audio call, once the SIP session is established, the media goes over a separate channel using separate protocols. So with the Lync server SDK, you don't necessarily have access to that media as it's going back and forth. But because the media is set up using information that's transmitted over SIP, you do have a lot of control over how the media channels get established, what ports and what IP addresses the media is going between, and things of that nature. So you just still have a lot of control over media. Before I move on, are there any questions about any of this? I'm trying to go at a moderate pace so as not to bore those of you who are familiar with SIP, but also not to confuse those of you who are not. Looks like we're good. Okay. I wanted to do a little bit of a sort of visual of what it looks like when Lync server is routing a message. And this will tie into the process that you're able to modify with the Lync server SDK. So what I have here is most of a SIP invite request to kick off a call. And I've excluded the body of the message, which would have some media information, just because there's only so much room on the slide. This is what the message would look like when it's coming from the Lync client to the front-end server. And I want to call it a few things here. I hope you can see the color there. The first line, which is the request line, at this point has an address of record, a SIP URI that's just tied to a user, not to an endpoint. The same goes for the to URI, the to header. And in fact, the SIP URI and the to header and the request line are the same because we don't yet know where we're routing this message. That's what Lync server will figure out. You can also see that there's a tag parameter on the from header. And that's because we already know the endpoint it's coming from, because that's the endpoint that's sending it. But there's no tag on the to header, because it could potentially go to multiple locations. A few other headers that are interesting here. The contact header identifies the SIP URI at which we can reach the originating endpoint of this message. So that tells the recipients, if you need to go back later and contact this specific endpoint, that's the URI you can use. And you can see at the end of it, there's that GRU parameter. That tells us that's a GRU. It's globally routable user agent URI. It's unique to this endpoint. Then there's the user agent header. User agent header tells us what type of user agent this is. In this case, it's the Lync client. You could also determine if it's a Lync phone edition device or a different version of the Lync client or a mobile client or other things of that nature. Okay, so the message goes into the front-end server. The front-end server now has some processing to do to figure out where to route it. And it looks at the to URI to determine this. Now, on the front-end server are a number of these different services, which are built using essentially the same framework that you have access to with the Lync server SDK. And these services do a number of different things. They perform routing tasks. They can route messages to each other when they figure out that another service has to handle it. And they're all located, if you want to check them out, in the server/core directory on the front-end server. So you can go in there and see some of the names of the services that Lync server uses in the core product. So here are a few of the examples: client version filter, translation service, inbound routing, or as it used to be called, default routing, user services, outbound routing, so on and so forth. I'll talk about what a few of those do. The translation service is an example of one of these services that are built on this framework. And the translation service's job is to perform number translation. So it looks at the to URI, and it says, first of all, is this a phone number? In this case, it's not, so there's nothing for it to do. If it were a phone number, it would use the translation rules that apply to this particular message, depending on the various policies that are in place, and it would do number translation, and then it would pass the message along to the next service. Then we go into user services and intercluster routing. And these services have, at a high level, two different jobs. Well, each of them has one job. The intercluster routing service looks at the domain, the SIP domain that's on the SIP URI and the to header. And it says, is this a SIP domain that's serviced by this pool of front-end servers? If not, where do I need to send it to? What other pool does it need to go to? If it is, then it passes the message along to user services. User services then says, okay, now that we know it's in this pool, which front-end server is this user homed on? Is it this specific front-end server that we're receiving the message on, or is it a different one? If it's a different one, then it passes it along to that front-end server, and we start the sequence over from the beginning. So let's say that we're on the right front-end server already. Next, we have inbound routing. Inbound routing's job is to say, now that we know we're on the right front-end server, that user is homed on this front-end server, we need to figure out where to send the message so it will reach that user's currently signed-in endpoints. So it looks at the user's currently active registrations, and it forks the message if necessary and sends it out to all of those endpoints. And at the same time, it applies things like the simultaneous ring settings and call forwarding settings that the user has in place. And at this point in the routing process, you can see a SIP response go back to the user's Lync client, and it's 101 progress report. And in the some of the headers that are in there, you can see there's, first of all, reference to inbound routing, but also some information about where, what number of endpoints this message has been proxied to, and which front-end server it's being handled by. At this point, the SIP invite is forwarded along to the actual endpoints for the user. It could be more than one, but I'm just showing one here for simplicity. And the key point here is that at this stage, Lync server has figured out physically, from a network perspective, where does this message need to go. So now we have an actual physical SIP URI in the request line. The to header is still the same. It still has an AOR, an address of record, but we now know where specifically we're routing the message to. What I've just shown you, that whole process, is the process you have access to and a certain amount of control over with the Lync server SDK. And there are a number of things that you can influence as Lync server is doing that routing. First of all, you can actually change where the messages are routed to. So you can tell Lync server, use this physical SIP URI rather than the one that you would normally use based on inbound routing and what it determines. You can also change the contents of the messages. You can add SIP headers. You can remove SIP headers. You can modify SIP headers. You can modify the contents of the message. So if you have an IM, you can change what's in that IM, add a disclaimer or something. And then last but not least, you can just look at the messages and extract information from them. So if you're doing statistical analysis of presence, for example, you can relatively easily just look at the contents of those updates and say, okay, I have this many people who are available and this many who are busy, and this is when they change their presence, and so on and so forth. If you have compliance needs, you can actually block messages from going through when they shouldn't. Or you can take the contents and extract them and send them off to some other data store, or even run them through a check to figure out, are the contents of this message something that we can allow to go through, or do we need to block it? So let's look at how we actually do this with the Lync Server SDK. So I talked through some of the scenarios just now. These are some of the more common applications of this SDK that I've seen in the field. Blocking traffic, modifying message content. Another one that comes up a lot, and I'll talk about this a little more in my UCMA session tomorrow, is rerouting messages to a UCMA application. So a few cases where that's useful. Let's say you need control over recording of calls, or you need to play a message on certain types of calls. You can grab the message using the Lync Server SDK and say, Lync Server, don't send that message to the user that person was trying to call, or the phone number they were trying to call. Actually, send it over to this UCMA application. The UCMA application will then play a message or ask for a password or whatever the case may be. And only after it's done that, or recorded the call or whatever, will it pass it along to the original destination. I mentioned earlier you can integrate with third-party devices or software. You can make whatever modifications you need to make to the format of the SIP messages so the other platform will support it. And then finally, you can fine-tune some aspects of how Lync behaves on PSTN calls or federated communications. So you can say, maybe I don't want to allow certain types of messages to go to federated contacts. We want to be able to communicate with them, but we don't want people sending file transfers, or we don't want people sending specific types of files or specific types of IMs. Or maybe when people call a federated contact, we want to make sure that call is recorded. But it doesn't have to be recording all calls. So now I want to dig a little bit more into the technical aspects of the SDK, because I'm sure that given this is a 400-level session, that's what most of you are here for. The applications you build with the SDK run on the front-end server or in a limited number of cases on the edge server. They handle messages, like I mentioned, as they're being routed through the server. Unlike, let's say, UCMA, you have access to all messages that go through the front-end server. Anything that's on there you have access to and control over. The applications are installed and configured using Lync Management Shell. And there are two types, script-only and managed. And I'll talk about the differences in a minute. But first, I want to just warn everybody that as you're using these APIs, you can do some serious damage. You can really mess up Lync server routing. You can bring down the entire front-end server or prevent messages from being routed. And in that respect, it's different from pretty much any other set of APIs available with Lync server. With, for example, UCMA, or with the Lync Client SDK, there are safeguards in place so that at most you can really bring down your own application. With the Lync Server SDK, the sky is the limit. So it's very important when you're building these applications to test them thoroughly, not just for stability, but also for performance, and to test them in a lab environment where you're not going to interfere with actual operations. So there are two types of these applications. script-only, and managed. Script-only applications are entirely contained in this text file called a manifest file. There's a script in there that Lync server compiles, or you can compile in advance. And the way it runs is optimized to operate at a higher level of performance with Lync server routing. So there's a smaller set of things you can do. You can't, for example, delete or modify existing SIP headers and messages. And you don't have access to all the external resources you have if you're developing in C# with a managed code API. But because the performance is better in general, if you're doing simple routing tasks or if you don't need access to external resources, this is the API, this is the approach to choose. Managed applications use a managed code API, which has a few different names. Some people call it managed SPL, SIP application API. You'll hear different things. But the point is it's a managed code API that you can use to modify routing in Lync server. These applications are generally deployed as a Windows service. You can also use a console app for testing. And there's more potential for performance impact. So you need to be a little more careful of what you're doing in the scripts and minimizing the impact. However, you can do a lot more stuff. You can modify messages to your heart's content. You can remove things. You can modify the message body however you want to. And because it's a managed code API, you can do anything you would in any other C# application. Access a database, call a web service, whatever. Again, you just need to make sure that the performance impact isn't a problem. Any of these applications start with a manifest file. The manifest file is a text file. It has a .am extension, and it's deployed on the front-end server. Inside the manifest file is some XML. Looks like this. This is a shortened one, but looks something like this. And the manifest file has two things in it. First, it has these different attributes that tell Lync server what messages to send or what messages can be handled by this application. So I'll call it a few pieces of this. The app URI, which is the one highlighted there, is kind of the identifier for this application. Lync server uses that to figure out which application you're configuring when you set it up. Then there's this request filter that determines what messages go to the script, to the application. And there are a few different attributes here that we'll talk through later. The most important ones, most important elements in here are the request filter. That's which SIP requests are handled by the application. Response filter, which determines which responses, SIP responses, are handled. And then the script-only element. And as you might expect, script-only tells Lync server this is a script-only application. There's no managed code to look for. The other piece of the manifest file is the script. And the script is written in something called SPL, SIP Processing Language. You sometimes also hear this referred to as MSPL, Microsoft SIP Processing Language. It's got sort of a C#-like or C++-like syntax. And it's got this limited set of functions and preset variables that you can use to perform those routing operations. So you can access the headers and the content of a request or a response, and then you can tell Lync server what to do with it. These are some of the more common functions that you use to tell Lync server what to do. Proxy request is to send a message along to a location of your choice, or you can just tell Lync server, go ahead and send it to wherever you want to send it, wherever you were originally going to send it. Proxy response does the same thing for a response. You have a set of 3 messages to control forking if you want to send a message to multiple locations. And then you can also respond directly from the front-end server. So if you want to say, you can't even get to that user, we're just going to block you here or redirect you. That's another option. This is what an SPL script looks like. VJ will be showing some live examples of that later, so I'll skip through this a little bit. And the final piece of the Lync server SDK is the SIP application API, or managed SPL. It's a .NET API. Does a lot of the same things as SPL, but it's managed code, and it has a slightly larger set of capabilities. Because it's managed code, it can be slower. There's those performance considerations that I mentioned. And it's always used in conjunction with an SPL script. You use the SPL script really to capture the type of traffic you want, and then dispatch specific messages that you need to handle in managed code. So the key here is to minimize the number of messages you dispatch to managed code to reduce the performance impact. And you send those along to the managed code from SPL with these two methods, which you'll see VJ go through a little bit later. The first one is to send a message to managed code and let the managed code make a decision on where to route it. If the managed code just needs information about what's in the message, but it doesn't need to make a routing determination, the higher performance option is to use dispatch notification. And that says, send this along to the managed code, but don't hold up the routing. Go ahead and forward it along. And this is, again, what dispatching looks like. VJ will show an example of this in a couple minutes. And this is an example of some managed SPL. It's pretty typical looking C# code with a few specific classes that represent Lync server routing operations. And then the last piece is there are a few setup steps you need to go through to prepare your application in Lync server. VJ will be walking through that in a minute. But the set of commandlets that you use in Lync server management shell are the -cs server application commandlets. New -cs server application is the one you use to create a new entry, a new record for your MSPL script or your managed SIP application on the server. These are some of the parameters that you use to configure it. If you remember the URI that I showed you in the manifest file, that's the identifier you use here to tell Lync server this, the settings we're setting up here, this is the script that those correspond to. And another important piece is this priority value. Because Lync server is running through the scripts on the server in sequence, the priority value determines when in that sequence your application has the ability to handle the message. If your priority value is lower, which means higher priority, you get to look at it first. If it's farther down in the sequence, then you may have already had some other scripts run and even possibly decide where to route the message before you get to it. And finally, the critical parameter tells Lync server, don't even start the front-end service unless this application is present. So for compliance applications, that's an important one because you don't want to have a gap where your application goes down and suddenly traffic gets through that shouldn't. If that property is set to true, your application is essential to Lync server functioning and it will just go down if the application fails. Now, conversely, if you don't want that to happen, you want to make sure that property is set to false. I don't have time to go through all these troubleshooting steps, but these are some of the more common issues that come up with both script-only and managed applications. Because of the number of security considerations and things like that, there are a number of groups that you need to add the service account to. There are those configuration steps that I mentioned in PowerShell. So if one of those things is off, you may have trouble running your application or getting your script to function. At this point, I'm going to turn over to VJ. He has some sample code to walk you through and show you how the Lync server SDK works. And then after that, we'll take some questions. So
all right.
Over to you, VJ.
Thank you. So let's see if I can switch over. 8. Beautiful. So what I have written here is a simple SPL application. Now, the first one I want to show to you guys is the what I call the ethical wall demo. It's basically you have sets of users in the company who are not allowed to communicate with each other. So how do you prevent communication between those two sets of users? I will show a demo of this, and then we'll take a quick look at the code. This one is a managed SPL application, because typically, anytime you want to add business logic to your processing, that is the time for you to go to managed SPL. The script-only applications can do basic message processing. So anytime you have additional business logic that you want to add on top of the routing, like if you want to go look at some database to get the user groups and find out who can talk to whom, those kinds of things you are better off doing in the managed SPL land. So I don't have the app running right now, so I'm just going to show that these two users can talk to each other. Yeah. So this guy gets a message, and he says howdy, and they're all happy. They are able to communicate with each other. So the first demo I want to show you guys is I'm going to start the application that I wrote, the sample application that I wrote, which will prevent these two guys from talking to each other. So this one is, as the usual caveats of sample code, I set myself a challenge that I should be able to write this in 45 minutes. Took me a bit longer. So I make no comments about the code quality. But the part that I want to highlight is the typical managed SPL boilerplate stuff that you want to add to get your application off and running. Running? All right, let's give this a shot. I can find out if this guy is running. You're blocked. So as soon as you send the message, you're blocked. Now, as a typical developer, I don't spend too much time on the UI portion of things. So basically what this guy does, as you can see, is that the invite request got a 403 response. That is all you see here. So, so let's take a quick look at the code sample. So I added some console output to say that I'm rejecting requests and so on. So let's look at the code sample. So the first part I want to show you guys is the .am file. Okay, as Michael pointed out, you have the application manifest XML file with the app URI and then a bunch of request filters, response filters. For this particular application, I'm not interested in responses. So I say, don't send me any response codes. And I'm only interested in invite messages. The other important thing that I would like to highlight here is this one, allow registration before user services. Now, as we mentioned earlier, we have a bunch of SPL of applications running in a queue. And you have the right to insert yourself in whatever portion of the queue you want by setting the appropriate priority. Now, as we talked about, user services is the application that does user routing. Now, if you're beyond inbound routing, then the request URI is the physical address, which doesn't make sense for us to do when we are doing ethical wall kind of thing, where you want to look at the source and the destination users. So in this case, I just allowed this guy to register before user services. If you're going before user services, this element is mandatory. And then down here, this SIP request is a built-in variable that tells you that it's a handle on what request you're on the request object that you're getting. And all I'm saying here is that if this is a request, then I'm just checking for the standard method. And then I get the from and to user URIs from the headers. And then I just dispatch it to the managed application. So the SPL portion of this this guy is very simple. You just get the request. If it's an invite, then get the from and to header, the AORs, and dispatch it to the managed application. Now, I could reasonably do the same thing in managed application as well. I will get the request object, then I can go through the from header, I can go get the request URI and look at the AORs. But this one, I just want to show how you can use some of the built-in functions in script-only SPL. You can also create your own SPL functions and call them in the same AM files. You can create your own custom functions to make your life easier if you keep repeating the same task, but we also have a bunch of built-in functions. Now, once you dispatch out to the managed application, the dispatch function call, the first parameter is the function name that needs to be called. That will be invoked. So, if we, okay. So this is the dispatch method. So in managed SPL, the dispatch methods have two parameters. You have an object sender and then a request received event args. And this event args will tell you the server transaction. You can get the request itself, and then you can also, from the request, you can get the content, do whatever processing that you want to do. You have access to all the headers, zip headers in the request. So you can look at the content type, figure out how you want to process these things. And also you have flexibility to add, remove headers, and so on. So this one is a pretty simple application that I wrote. All it does is it gets the parameters that are passed from the script SPL. The two parameters that we passed are sent in as event args.parameters, and then you get the parameters, and then I just wrote a lazy function that says, are these two guys allowed to talk to each other? And it returns a bool. If they are not, I just say rejecting request. I create a response, 403 response, and send the response back. And if they are allowed to talk to each other, I just proxy the request. Okay, this is a pretty straightforward application. Now there's a bunch of boilerplate stuff that I have skipped over. Okay, let's take a quick look at this. Now, one of the first things that you want to do when you start your application is connect to the server. Okay, so when you install Lync server SDK, you have a bunch of DLL, server agent, DLL, and other guys available. On the Lync server, these DLLs are added to the GAC. So when you start your application, you try to connect to the server, and this is pretty much boilerplate code. You can figure out how many times you want to wait to connect to the server. And then once you're connected, you take your application manifest file, and then you compile it, and then you create a new server agent object. So as I mentioned, the server agent is the layer in the managed layer that takes messages from the Lync server and hands it off to your application. So for you to all your communications with the Lync server, including receiving messages, sending responses, are done through the server agent layer. Okay, so it's very critical that you connect to the server, instantiate a server agent object for yourself. And then the server agent has a bunch of helper events that you can register to. I just showed you one example. I'm just got one guy who's connection dropped handler. If your connection to the server dropped, you get a callback, and then you figure out what you want to do. It may be because the application was disabled by the admin, or it may be because there is some connectivity issues, or you're being too slow processing the response, so the Lync server app decided to disconnect you. It can do that if you're not critical. So the other interesting piece that, remember I told you it took me a bit longer than 45 minutes? This is the part that took me longer than 45 minutes. Once you connect to the server, you want, in your main program, you want to have this loop going. Basically, every time the Lync server wants to dispatch a message to you, you get a callback on an event handler, and you have to tell the Lync server what to do with the callback. For most applications, it's just server agent, you go process this event. And when server agent starts processing this event, it will say, oh, this is an invite. This is the type of invite that you are interested in. And you've said that your dispatch handler method is this one, so let me call you back on that guy. So any questions on this so far? You want to increase the font size?
I saw a default conditional there, which was like, is ethical firewall, or is ethical something? I assume there's a big old library of those.
No, this is just my. This is where your business. This is where your business logic fits in. So I can show you my version of is ethical.
Yeah. Curious.
This is what happens when you give me. Let me do something.
C# has its built-in ethics detector.
That's what I was wondering.
Yeah. Now this is just quick and dirty. So what I have is a dictionary, a string and a byte. So each user has a group byte, and I do a bitwise AND of the groups and say if the bitwise AND is 0, then they're not allowed to talk to each other. So the example that I had. This code is basically a very modification of whatever is on MSDN, except for the ethical wall thing that I added. This code is just a modification of whatever is on MSDN. And when you install the server SDK, you have a couple of sample applications. In fact, speaking of sample applications, I would like to show you one of the sample applications that we have. Let me see if this guy.
And each just get installed as filters.
Pardon?
Just some of these pieces can get installed as filters, pretty much in the filter list.
Yes, any SPL application that you write, you can install it as a as a filter. Ooh. Oh, I'm on the client. Yeah. So these are all the filters already there. And the one that we added, if you look at the server, this line, we just added this new application in the filter list for the server, enabled to true, and the priority is 0, which means this will be the first guy that gets a crack at the message. Yes, these are set to the pool. In fact, you can only set it to the pool. You cannot set this at individual FE level. This is the other one.
Question.
You had a question? Yeah.
What is the best practice for priority of customized application?
Sure. So
there's a batch of 7, I guess.
Repeat it. So the question is, what is the rule of thumbs that you want to follow for setting the priority of your applications? So to understand what your priority is, you need to understand what Michael talked about earlier, which is what are the existing applications in the dispatch chain. So typically, when you're acting on behalf of a particular user, you want to know whether the first important question you want to answer is whether you want to run before user services or after. And for example, if you are interested in conferencing messages, or if you're interested in presence messages, those types of messages are handled by user services. So which means that you certainly have to be before that application. Okay. The other essential data point for you is do you care about actual routing filters, meaning you want to block requests or not? So as we mentioned earlier, inbound routing is the guy who does the forking. So you want to know whether you want to catch it before the forking happens. That way you can either reject the request or even influence the forking by retargeting the request to somebody else. Okay, so these are the two essential points that you want to think about.
I think one other consideration is that in some cases, you need your script to see something that's done by a previous application. An example is the translation service. If you run before the translation service, you won't see number translation. It only will show up in the message if your application runs after that's taken place. So you can look at the priority value relative to that application.
Yeah, I did used that famous caller ID script for a while, and it did not sit in fourth and fifth place. It just did not run at all. It needed to be ahead of a couple other pieces, no matter what.
Right. If it's too late in the sequence, then something else will have already said, here's where it's routing to.
Yeah,
and then you don't get it.
Sit up there on the list somewhere that I didn't realize until I put it in the right spot.
Okay, so let me try another test here. So these guys are now able to IM each other because I stopped the applications. And then if I just say echo, and this guy gets echo, echo. Okay, this is one of the SDK, one of the script-only applications that is in the samples. And all this guy does is, anytime I see an echo, just concatenate another echo. Okay, so
you can see the many business applications of this script.
Exactly. You could use something like this if you want to do URL filtering, and or if you want to look at what kind of messages that go through, and if you want to display warnings and stuff like that.
Special types of disclaimers, depending on who you're contacting, for example.
Yeah. So this one, in this case, we went ahead with a script-only application that is in the sample, and it works fine if the IM format was plain text or HTML. If the default IMs were sent on rich text format, then the coding is different. So if you want to process these kinds of messages for rich text format as well, then you want to switch over to a managed application and use the default .NET encoding text formatting libraries. Okay. Any questions? Yeah.
Do you have any recommendations on how to, let's say that you were going to have this as sort of a voxel product and you wanted to automate the setup process so that your users don't have to run PowerShell scripts to set this up?
Mm-hmm.
I mean, I've tried to do this before through install shield, things like that. It's a disaster to get the user accounts correct.
You can
Repeat the question for the recording.
Oh, yeah. Let me. So the question is there any way to wrap the installation of the application, especially the PowerShell part, along with the MSI, so that your end user admin doesn't have to run PowerShell scripts? So for you to deploy your application, there are a bunch of steps that Michael had in the troubleshooting. The first one is that you need to add the account that is running the application to RTC server applications on the front ends. Okay, that part is certainly scriptable. Now, once you've done that, deploying the bits in the right folders and then running the PowerShell command, it should be pretty straightforward for you to invoke PowerShell through a batch file. And typically, when I give some privates to some testers, that's what I do. I just give them a batch file, and that invokes PowerShell, because you have PowerShell deployed on all the front ends. So you can just invoke PowerShell, pass your own script, and do the whole thing on your side. The one part that you want to be wary about is the priority, because if you are familiar with what are all the applications that the customer has already deployed, then you can set the priority on your own. But if the customer has some other applications already running, then you got to look at, you want to be a bit more flexible on how you set your priority. Ooh. Any other questions? Yeah.
This is a question related to deploying the library desktop.
Mm-hmm.
How would you get around doing that automated?
The question is, how do you deploy the application manifest file, and how do you automate it? I presume that the question is for a script-only application manifest file. So here again, if you look at the samples, it's just a simple batch file that just copies files over and runs the deployment.
But you need to copy it to your client server.
Yes, you need to copy the .am file to every single front-end instance in the pools where you are deploying it.
Because typically, like for us, we're installing on a different box.
Mm-hmm. So installing on a different box, I strongly encourage you to use the PowerShell tools available. We have, in our internal deployment environments, we have automated all these deployments on copying .am files and stuff like that over. So there are PowerShell scripts and PowerShell commandlets that you can use to copy files and execute remotely and other fun stuff. So I strongly encourage you to look at PowerShell. Yes, sir.
Just as example, could you tell how to approach programs that script that check user agent version,
Uh-huh.
and depending on user agent version,
Yeah.
do some decision. How would
So that is the bread and butter of MSPL. In fact, if you know what user agents that you're looking for, in your SPL script, you can get the value of the user agent header and see if the string matches, or if it's a substring or something like that, and only in those cases dispatch it up to the managed app.
So it's a built-in property?
Oh. We can take that offline.
Yeah.
Yeah. So the basic idea is that when you get the SIP request, you have access to all the headers that are in the SIP request in both the script-only layer and the managed layer. So you can get the actual value of a particular header and see if it's of interest to you, and then take actions based off of that.
So there's a function that allows you to get all headers that match a certain name, header name. So you'd pass in user agent as the name. It would return all user agent headers, which should just be one. And then you would just do a string compare.
I'm more into the response message.
Mm-hmm.
There's a function that you can call in SPL that will send a SIP response. So from your script, you can you call that function and you say, I want to send, let's say, a 403 response, 403 forbidden, and then you can put in additional information if you want to explain why you're sending that response, et cetera.
Yes, sir.
How do you differentiate between a SIP message for an IM and a SIP message for voice?
So the question is, how do you differentiate between a SIP message for an IM and a SIP message for voice? Both of these requests are invites, but the content types and the actual content would be different. So IM it's also SDP, but if you know how the SDP RFC, the audio invites will have an audio M line. So if the audio M line is present, then that's an invitation for an audio conversation.
So you look for a line that says M equals audio in the body, and that's it. If you see that, it's audio.
In the SDP content.
In the SDP.
And you have access to the SDP content in both the script-only layer and the managed layer. Yes, ma'am.
Question about routing. If I, let's say, want to reroute a message that went to user A to user B, so I'll figure out the logic, and now I want to process the request to user B.
Mm-hmm.
Is the routing rules will be now applied for user B, and am I supposed to find where the user B is located, or is it not?
Okay, the question is that if you retarget a request intended for user A to user B, do we have to do anything extra to figure out the location of user B? And does that paraphrase your question? The reason I smiled was because yesterday when I was talking to Michael about these things, I said, okay, this is one important point that we should cover. And thank you for feeding in that line. So as you saw that in the dispatch chain, you have various applications running. If you're running after user services, then, and you retarget the request, you may not be able to get the request to the right home server. So typically what you can do is that if you know you're running after user services, then you can add an mAddr parameter, which is a parameter that you can set in the request URI, and route the request back to the same pool and run the entire gauntlet again. Is there a dump of that? An example? I'm not sure. If you can catch me offline, we can take a look at that. Thank you. Yes, sir.
One of the things he was discussing was performance.
Mm-hmm.
You can obviously test your scripts in the test area, but there's no real way to match the production performance. Do you guys have any suggestions?
So the question is, how do you test performance? You can test functionality in your test area, but how do you test your performance in your test area, in your test bed? So the short answer is that you have to simulate the load. We typically use UCMA to simulate the load that we want to test our performance. So you can create endpoints from UCMA and stress the system to see how fast you're handling. Now the other thing that you want to keep in mind is you want to make sure that you are not taking more than, say, a fixed amount of time to process messages, and you need to invest in some perf counters and stuff like that, so that you can keep track of how much time you're taking to process messages, what are your main bottlenecks. But the short answer to your question is you got to write test applications that will simulate the load.
There are also some open source SIP load testing tools that you can use for that purpose. You just use them to pump in traffic through the mediation server.
Any other questions? Yes, sir.
So creating your own busy application
Mm-hmm.
would be quite easy. Or is there anything you need to be very careful about?
So the question is, creating your own busy on busy is quite easy. It is relatively straightforward. I believe there are some partners who have done their own version of busy on busy.
But if you create on your own environment.
I think what you're, if you get a product, what you're paying for is essentially things like the performance testing that we were just talking about. It is definitely quite straightforward to create some applications that hit those scenarios. The part that's not straightforward is making sure you're not impacting anything else, testing it for performance and stability.
Yeah. Because when you do busy on busy, you're reading into the DB to get the present state and so on. So that part has some serious perf implications. All right. Okay.
We have a couple of resources, links up here. The MSDN documentation is a good source for, what are the names of the functions, what do they do, how do you do specific things, and then also the SDK download. The SDK includes both the binaries for the managed code API and also some sample applications, both script only and managed code. So that's a great place to start for examples and just to poke through some code to see how it works.
I also would like to, maybe you can repeat that for recording as well, point with the blogs that have been, or the MSDN technical articles that have been written by Kurt Ding. Because, for example, the question that you asked about how to check presence of all users, it was largely explained by him in his presence schema article. And there is actually in the TS of the download the TS PhD of the 2010 server,
So for the benefit of the recording, the recommendation is to check out the blog post by Kurt Deding for some examples, including one dealing with presence. Any last questions before we wrap up?
Have you guys seen any future into the SDK, like database calls, being able to access database tables and things like that?
So the question is, are there plans to add features to the SDK like database calls?
So the
That way,
SDK is primarily intended for routing, and the very fact that we have managed extensions to the SDK means that you have access to the database, whatever store that you want, by using the standard .NET APIs. So in that sense, we don't see a need for extending the SDK to provide access to some database store, because most database stores for custom applications are pretty much custom.
There is, we didn't mention this earlier, but there is one type of data you can access from a script. You can go to a flat text file.
Yeah, that's what I was
So,
referring to. Is I thought it would be nice to have been able to put those into a table somewhere instead of a
right.
text file.
Yeah, I think what I've seen some people do is just have another application that grabs data from a database and puts it in flat file format.
Yeah.
It's not the most elegant way of doing it, but it works.
Yeah, and I want to call out that the flat text format has some limitations in terms of size. No files can be more than 128K, and you cannot have more than 4 files. So depending on the type of application that you want to write, the flat files may work for you, or they may not.
Okay, we're out of time. So thank you, everyone, for coming. If you have more questions or specific things you want to talk about, I think we'll both be around for a few more minutes. So feel free to come up and chat with us. Enjoy the rest of your day.